Okay, so question 4. We've got this inflatable ball, surface of the sea, current from one. Okay, so we've got this current and we've got the wind. Initially, the ball is at the origin. Find the distance traveled by the ball when t equals 10. So we've got, right, we start at the origin and we've got a current which goes to, that's I and J, right? Current which goes 2I plus J. So that's the current. Current 2I, well 2 and J, so just 2 1, and the wind which is 3I minus 2J, so it's like that's the wind, isn't it? 3I minus 2J, and so the resultant, which is the total, is going to be 2 1 plus 3 minus 2, which is 5 minus 1. So that's the force on the ball. Okay, we've got mass, what the distance travelled, 10 seconds. It looks like it's a constant force, isn't it? Constant acceleration. So why don't we use F equals ma to find the acceleration? So the force, which is 5 minus 1, is equal to the mass 0.1 times the acceleration, which implies the acceleration is going to be times both sides by 10. We get 50 minus 10. That's the acceleration. Looks like a Suvat equation. Constant force, isn't it? So it's going to be constant acceleration. So it's Suvat, but with vectors. So what do we want? Well, the distance travelled. So that's what we're looking for. Our initial, does it say the ball is at the origin and has velocity? So its initial velocity is 1 1. Time is 10 seconds and the acceleration is 50 minus 10. So we've got everything we need. We've got S, U, A and T. S, U, A and T. S equals U plus S equals UT plus a half AT squared. We're looking at that. So distance is equal to U times T plus a half times A times T squared. So we look like that, isn't it? So S is equal to 10, 10. Half times 100 is 50. 50 times 50 is 2,500. 50 times minus 10 is minus 500. Okay, so S is equal to 2, 5, 10 and minus 4, 90. But we want the distance. Distance is not a scalar. That's a scalar, isn't? Sorry, that's a vector. Distance is a scalar. We want the magnitude. So distance is equal to the square root of 2510 squared. It's Pythag, isn't it? And we need a new pen. Okay, right. Minus 490. 490 squared, which is equal to I got 2557. How many decimal places? 2 decimal places can't hurt. Meters. There you go.